In the last video, we have talked about midterm formula and distance formula for a line. And in today's video, we will be talking about the slope of a line. So first, let's take a look at the definition of the slope. So the slope or gradient represents the steepness of a line with respect to a ratio between the rise and the run. So the two key terminology we should know is steepness and ratio. And the rise and run will delve into those two parts very soon in today's video. So in other words, slope represents how fast the line is ascending or descending. So for example, if a line goes like this compared to a line goes like this, we can clearly see that this line increases in a faster rate than this line. So which means this line has a greater slope than this line. So the formula for slope would be rise over run. So let's take a look at an example to talk about what is rise and what is run. So example number 1. Determine the slope of line AB or line segment AB to the nearest 10th. So we can see that the slope that we are looking for is for this line segment right here. And we can see that in the diagram, it has already constructed a right angle triangle for us, ABC. And we can see that AB, the line segment that we are looking for, serves as the hypotenuse. And we have two legs with known distance. One is 0.6 meter and one is 1.9 meter. So we can see that if we want to go from A to B, we have essentially two ways. So the first way is to go directly from A to B like this, following the highlighted parts. However, we also have a second way, which is to go from A to C first, and then go from C to B. And therefore, we can actually see that for AC, we have a direction to the right, and for BC, we have a direction to the up. So this to the right direction, this AC would be run, because it runs to the right, and this BC would be a rise, because it rises from C to B. Therefore, we can apply this formula right here, m equal to rise over run. So we can say m equal to rise over run equal to rise is BC, run is AC, equal to, we substitute the distance in 0.6 meters and 1.9 meters, and we will get approximately 0.3 meters. And this would be, no meters, because the unit cancels out. So we will get approximately the slope for segment AB will be 0.3. However, this formula is not general. It's not a generalization of how we can calculate slope for every single case. So let's investigate what is the slope formula in general instead of saying rise and run. How can we use mathematical expression to formulate slope? So first, let's take a look at how we can find the slope using graph and the original formula, which is m equal to rise over run. So we have this formula right here. We have a line segment AB, and A has coordinates -1, 1, and B has coordinates 1, 4. So let's construct a right triangle as well, just like the last example, something like this. And we can clearly see that if we want to go from A to B, we have also essentially two ways. One goes from A directly to B like this, and the second way is we can go from A to, let's say, this point C here. So we go from A to the right to C, and then we go from C to B. So basically, we can still say that m equal to rise over run, and in this case, we can see that the rise would be the part where we go from C to B. So one segment BC, and run would be the part where we go from A to C with a direction to the right, so line segment AC. And next part, we will try to figure out the distance between point BC and the distance between point AC. So we can see that if we plot the data out, if we plot the coordinates out, we can see that this B right here corresponds to a Y value of 4, and this A corresponds to a Y value of 1. So this BC, the distance between point B and point C, corresponds to the distance on the y-axis between 4 and 1, which is 3. So the distance between point B and point C, which is the distance of line segment BC, is 3. Similarly, we can see that point A corresponds to a x coordinate of -1, and B corresponds to a x value of 1. So even though this graph is not very drawn to scale, but we can see that the distance between point A and point C is exactly the distance on the x-axis between -1 and 1, which is 2. So we can just substitute value in, and we can get the slope of line segment AB would be 3/2. Okay. Next, let's take a look at how can we construct a general slope formula. So it doesn't hurt if we construct a right triangle again. So we can draw something like this, just as what we did for the previous 2 examples. Make sure it's a right triangle here, and we can call it a C. So if we want to calculate the slope M, we can still use right over wrong as our starting point. Then we need to figure out what is right and what is wrong. So as we can see, we can if we want to go from A to B, aside from the way that we can go straight from A to B, we can go from A to C first and then C to B. So the right would be line segment BC, which is where we go up, and the wrong would be line segment AC, which is where we go to the right. Next, instead of using real value, we need to use variables to represent the distance. So, same strategy for point B, we have a y value of y2, and for A, we have a y value of y1, and these values are pre-declared by us. And we can see that the distance between point B and point C is still exactly the same as the distance between y2 and y1 on y-axis. And the distance between that, if we think about it, would just be y2 minus y1. What about AC? We need to use x value this time. So for point A, we have a x coordinate of x1, and for point B, we would have a x value of x2. And the distance between point A and point C corresponds to the distance between x1 and x2. And if we also think about it, the distance between 2 points on x-axis would just be a simple subtraction. So the distance between x1 and x2 would be the greater minus the smaller, x2 minus x1. So this formula M equal to y2 minus y1 over x2 minus x1 would be a general formula for slope of a line. Next, let's take a look at several different types of questions that could be potentially tested after we successfully derived our formula. Question type 1, applying the formula directly. So we are just using the formula, substituting the value, and get the slope. Such as this question right here. Determine the slope of a line connecting the following points. And the points are A, -10, 8, and point B, 2, 8. So what would be a slope connecting these two lines? Without graphing, only use the formula. So m equal to y2 minus y1 over x2 minus x1. So before doing that, we need to consistently make sure that we declare, see, I made a mistake here. So we need to really be careful that we are declaring which one represents what kind of variable beforehand very carefully. If we say the x value of a is x1, then the y value of a must be y1 as well. It could be y2. So now we can just substitute the value in. So y2 minus y1 would be 8 minus 8, and x2 minus x1 is 2 minus negative 10. And then do a simple calculation. 8 minus 8 is 0, 2 minus negative 10 is 12. And this would yields a slope of 0. Surprising, hey? But if we think about it, after we apply the formula, let's do a simple sketch of the graph. So if this is the x-axis and this is the y-axis, where would this a fall? This a will have a x value of negative 10 and a y value of 8. So it would be somewhere here. What about b? B would have a x value of 2 and also a y value of 8. So it would be here. So we can see that the segment connecting AB is actually a horizontal line. So from this question, we can actually gain an insight. For any horizontal line, the slope will always be 0. However, if we encounter a vertical line, the slope will always be undefined. Why is that? If we think about it, if we have a point CD, both of them will have the same x value, which means that in this formula right here, in this formula, general formula right here, if they have the same x value, on the denominator, x2 would be equal to x1, which means if we subtract those two values, will give us a 0. And a 0 on the denominator would result in an undefined value for this fraction. Next, let's take a look at our second type questions. Question type 2, applying the formula with variables. So this time, not directly apply the formula anymore, not brainlessly substituting the value anymore. So let's take a look. P has a coordinates -1, 2. Find two positions for Q so that M, so the slope of the segment PQ equal to -2 over 5. So what can we do? So first, we still make sure that we grasp the formula. So the slope formula M equal to y2 minus y1, x2 minus x1. So let's say that P, the coordinates of P, is -1, 2, and the coordinates of Q, let's say that x and y, or A and B, just to clarify things a little bit. So A and B. Q has the coordinates A, B. And then we declare, let's say, P has x1, x2, and Q has y1, y2. Oops, sorry. This is y1. Oops, it's all messed up. So this is x1, y1, and x2, y2. So now, let's substitute some values in with variables, not just simple value substitution, which would be boring. So y2 minus y1 is actually b minus 2. And x2 minus x1 is a minus -1. So let's get rid of the bracket first. It is b minus 2 on top still, and a plus 1 on the bottom. And from the question, we know that the slope of this line segment is -2 over 5. So this would result in a -2 over 5. So if we do a simple cross multiplication, like this, we will get something like 5 times bracket b over 2 equal to -2 times a plus 1. And if we do a simple simplification, it would be 5b minus 10 using the multiplicative distribution property, and negative 2a minus 2. If we move the variables to one side, we will get something like 5b plus 2a equal to -2 plus 10, 8. So now this question transforms from a coordinate geometry question to a algebra question, to a equation with two variables. So how can we solve this equation? We don't have normally, if we have two variables, we need two equations to form a system of equation to solve both of the variables. But in this case, since the question is only asking for two possible positions, so we don't need to solve for every single case. So let's say, what about when, let's just give some values, when b equal to 0, what would a be? A would be 4. Let's say when b equal to 1, what would a be? A would be 8 minus 5 equal to 3 over 2. So see, we can just obtain two possible positions. We don't need to solve this equation necessarily. Next type of question is a bit more challenging than the previous two question types. So type 3, logical understanding. So this time we really need to connect those dots together and make sure that we have a very solid understanding of the concept of the equation of the slope. So let's look at the example. Point B is in quadrant 1, Q is in quadrant 2, R is a point in quadrant 3, and S is a point in quadrant 4. State if the slope between each of the points could be positive, negative, 0, or undefined. So let's take a look at this question. So if we draw a Cartesian plane, we have P somewhere in quadrant 1. So this is quadrant 1, 2, quadrant 3, and quadrant 4. So we have P somewhere in quadrant 1. We don't really care about the position. Q, quadrant 2, R, quadrant 3, and S, quadrant 4. So let's take a look. We have a few possibilities for the potential line segments that we can form with these 4 points. We can do QP, QS, QR, RP, RS, and SP. So let's take a look at each of them. So first, QP. How can we do this in a very efficient manner? The key is to identify the property of x coordinates and y coordinates in each particular quadrant. So in quadrant 1, x values will always be positive, if you think about it, because it's always on the positive side of the number line of the x-axis. So any point in quadrant 1 will have a positive x coordinate, as well as y coordinate. Every single point in quadrant 1 will have a positive x and y coordinate. What about quadrant 2? In quadrant 2, the points are still correspond to a positive y value, but this time they correspond to some sort of lie on the negative side of the x-axis, so the x value will be negative. For quadrant 3, not only the x value will be negative, but also the y value. And for quadrant 4, our x value goes back to positive, but the y value remains in the negative range. So now the question becomes much easier. So if we want to calculate the slope of QP, we would have the y. Let me just move this a bit over to here. We would have the y value for, let's say, P minus y value of Q over x value of P minus x value of Q. We want to make it very consistent. So yp is a positive number minus qp, yq, which is also a positive number. Xp is a positive number, while this xq is a negative number. So look at this thing. On the top of the fraction, we have a numerator, we have a positive number minus a positive number. However, we do not know which y value is larger. So we cannot determine if it would yield a positive value or a negative value. On the bottom, positive minus a negative. So the result will definitely be a positive number. However, since we don't know if we can get a positive number or a negative number or potentially 0 on the numerator, so this will give us a possibility of all three: positive, negative, 0. QS, if we think about it, it is it would be the y value of Q minus y of S, x of Q minus x of S. Y of Q is positive minus a y of S right here is negative. X of Q is negative, while minus a xq a positive. So we can see that on top, positive minus a negative, it's definitely positive plus a positive number. Negative minus a positive is definitely still a negative number, so it will yield a negative number for sure. So, same approach can be taken to tackle QR, RP, RS, and SP. And right here, I will give you guys the answer directly, and you can try to derive and solve every one of them. For QR, we will have undefined, positive or negative. RP, we will have always positive. RS, we will have still 0, positive, negative. They're all possible. And for SP, we will have undefined, positive, or negative. So these are the three types of classic questions that could be potentially tested regarding the slope of a line. And we also briefly talk about how we get the generalization, a generalized formula for a slope of line. We also talk about the starting point of how we can derive this formula, which is slope equal to rise over run, and what do rise and run represent respectively. In the next video, I will walk you guys through a challenge question, which requires a holistic application of the slope formula. I think that's all for today's video. Thank you for watching and have a good day.